Welcome to Stanford CS193p, spring of 2025, lecture number 1. I'm Paul Hegarty, by the way. I've been teaching this class for 14 years here, 15 years, something like that. I don't know, how long has the iPhone been out? Pretty much since the start of the iPhone coming out. Today I'm going to do this very brief course overview. Then after I do that, I'm going to start with a kind of brief tour of Xcode. People who have done assignment 0 have already launched Xcode and done some stuff, but I'm going to try and briefly explain most of the important parts because we're going to be doing all our work in Xcode, and it's a pretty big app. It's got a lot of features in there, so a tour is warranted. And then I'm going to dive into kind of understanding the real basics of building iOS apps with SwiftUI Views, okay, just the basics of it. And then on Wednesday, we will start building an app, okay, and we're going to take weeks to build this huge app, and I'll explain in a second here why we use that approach. So what's this course about? Building iOS apps, of course. You all know that's why you're here. And we're mostly going to build iPhone and iPad apps, but actually we're going to make our app work on Mac OS as well. And one thing that's really cool about SwiftUI is all the tools that you learn to build an app for an iPhone, it works for Apple Watch app building, or tvOS, or Vision OS. They're all the same tools. Now, you might not have the exact same code base running exactly on the other things, as you see when we start on an iPhone and then we switch over to iPad. It's going to be some slight differences, and then a Mac is another slight differences. But for the most part, what you're learning here, really portable across all of those Apple architectures. What are you going to learn in this class? I mean, a lot of what you're going to learn here is going to be kind of familiar to you, like probably all of you or most of you know object-oriented programming, and some of the stuff we're going to do looks kind of like object-oriented programming, but we're not actually doing object-oriented programming in this class. SwiftUI is not object-oriented. And then the language we're going to use is kind of looks like C-ish, but it's not, okay? It's a different language. It's Swift. So a lot of the things you're going to learn are going to be completely new. Okay, this language, Swift, completely new. It's a very modern language, incorporates all the best things from a lot of other languages, so it's a great language to learn, but it is a new language. And you're going to be learning functional programming, or some would say protocol-oriented programming, instead of object-oriented programming. Now, how many people in here have actual experience writing code in a functional programming language? See, almost nobody. Okay, maybe some people took CS43 or whatever that is, Haskell, that kind of thing, but it's pretty rare. Okay, so most of you, I'm going to assume you know nothing about functional programming. And protocol-oriented programming, similar. The other thing is probably going to be new if you've been building any kind of user interface on other platforms. SwiftUI is a reactive user interface platform. Now, the only other common reactive one that I see people have some experience with is React. Okay, there's something called React Native. It is a cross-platform reactive user interface development environment, whereas SwiftUI is just for iOS. So that's something I'm going to assume most of you don't have a lot of experience with as well. If you do know React, that's going to help you here, because it's a similar architecture for building UIs. And then we're going to do some ancillary things, like when we do our database stuff, it's going to be structured access to the database. So we're going to be accessing a SQL database, you know, tables and rows and all that, but we will access it at a much higher level, okay? What you would think of as objects, but it's not object-oriented programming, but kind of that level, a higher level. So you're going to learn that as well. And just in general, this whole course, it's a great place to get real-world experience, okay, with all the stuff you're learning in all your other classes. Okay, all these things I lifted at the bottom here, animation and CHI, obviously, and networking, multi-threading even, you're going to see all that happening here, and all collected into one real-world environment. So it's a super good synthesis class of all the other stuff you're doing. All right, prerequisites briefly. The number one prerequisite for this class is you have to have comfort writing a lot of code. Okay, so if you have not taken a lot of classes or done other projects where you've written a lot of code, you're going to find this is a lot of code to write. Okay, now that's not because there's anything about Swift or SwiftUI that requires a lot of code. It's just that I believe that if you want to learn a system like this, you got to actually write the code to do it. So I'm not going to be giving you take-home tests about concepts and all that. I'm just going to tell you to go write the code. And if you can write the code, then it's going to show me, oh yeah, you understood the concepts, because you just wouldn't even be able to do it otherwise. So if you're coming from an experience of having CS106A and B and CS107 and hopefully one or two or three of these other things like CS108, which I guess is object-oriented programming these days, and then CS43 I mentioned, CS110, I think you do programming in that, right? That's systems. Or CS147, I guess you could learn React in that. If you have these other things, then you're going to have enough coding experience where this is going to feel, okay, I can do this. So it's not extreme programming, but it's also not, if you're coming straight out of CS106A, this is going to feel like, oh my gosh, I got to write an awful lot of code here, okay? So that's the number one prerequisite for this class. I do think it's also important to know some structured programming language, object-oriented programming or something, not just C-like, level of programming, because we are going to use a very important structured programming approach to make our code understandable so we can build these humongous apps but still have them work and be reliable and debuggable and all that. We need a structure, and we're not going to do object-oriented programming, but it's another thing, functional programming, protocol-oriented programming, which is similar. I think it is a bonus prerequisite if you have already learned at least 2 languages. Because I'm going to teach you a completely new language here, okay? And so if this is only the second language you've ever learned, you only know Python, and now you got to learn a second language, that's going to be an extra burden on you this quarter, because you're going to be learning how to learn another language at the same time you're learning all the other stuff. So if you know Python and you know Java and you know C++, okay, this is going to be fine. You've seen multiple languages. This is just another one. Look, when you get to where I am, I'm old now, but I know dozens of programming languages. And if you tried to teach me a new one, I'd be like, whatever. It's because I understand all the different ways programming languages do different things, and it's like there's nothing new under the sun anymore. Okay, so the farther along you are on that spectrum, the better, because I am going to teach you an entirely new programming language. All right, how does the course work? Okay, what are the mechanics of the course? Well, Canvas and Ed discussion are crucial in this course, all right? Most of the communication I'm going to do is right here in lecture. I'm going to teach you how to do SwiftUI. But all the communication you give to me is going to mostly be Ed discussion. Now, I absolutely want you to raise your hand and interrupt me here in this class if you have a question. No problem with that. But a lot of times, you don't want to ask it in class, or you don't think of it till later, or you're doing your homework and you're thinking about it, and that's when you're going to hit Ed discussion. And I'm really good at answering Ed discussion questions really fast. Okay, you're probably already seeing that. Okay, so really, I can't emphasize enough. If you ignore Canvas and Ed discussion, you will not learn in this class. But when we're in lecture, most of the learning is going to be demos. I'm going to be writing code. Okay, writing code to use SwiftUI to build iOS apps. And that's what you're going to be doing in your homework as well. Okay? I always try to show you things 3 times. Okay, one time I will show you in slides or some kind of explanation. And then another time I'll write a demo. And then the third time you're going to do the homework. So you are really going to learn the stuff we're doing because you're going to see it multiple times. So the demos are really, really important. And I'm doing these demos in what I call a narrative fashion. We're going to spend the first 6 or 7 weeks in this class on one app. It's going to be very large by the end. But the reason I do this one app over 6 or 7 weeks is because I want you to get the feel of what it's like to build a big app. And I call this a narrative approach because it's like we're writing a novel together. You in your homework and me in lecture, where we're learning new characters and the plot and the settings. You see what I mean? And that all stays the same as we build this bigger and bigger app. Now, there's a different way to learn things like SwiftUI, which is what I call the vignette approach. This is the approach where you're like, I want to use a scroll view in my app. So you go to ChatGPT, or you just go to Google, and you say, how do you use a scroll view in SwiftUI? And you go to some web page, or ChatGPT spits back at you a little dozen lines of code or so that perfectly encapsulates, here's how you use a scroll view. You get a little vignette that's teaching you that. And so narrative is quite different, right? We're building this big app versus this little 12, 15 lines of code. Now, which is better, narrative or vignette? Of course, it's both of them together. Okay, that is the best. The best is when you can get the narrative underlaying, like I'm going to give you in the next 6 or 7 weeks, and then after that, you're going to pound on vignette learning. You're going to be doing Google and ChatGPT all the time to learn new things, new ways to do things I don't get to in the narrative, which is going to be a lot of things. Okay, it's only 6 or 7 weeks. So those things will go together. And you'll see it in your class because during the first 6 or 7 weeks, you'll be doing homework, which is inside the narrative. Okay, all your homework is going to be related to our narrative. And then when you do your final project, which is the last 3 weeks of the quarter, then you'll be doing vignette learning because you're going to be wanting to show me that you can learn new things. That's one of the most important things about the final project. Lecture slides like this, minimal, mostly for concepts. For review, like I'll do some slides maybe on Tuesday if we have time, reviewing what we did, just to keep it fresh in your mind. And then in terms of assignments, you've got reading assignments. For the first 4 weeks, I will be giving this kind of guided approach to reading the Swift programming reference manual. It's big because Swift is a big language. It's got functional programming in there. It's got object-oriented programming in there. It's got protocol-oriented programming in there. It's got all of it. It's got so much. It's a really great language, but there's a lot to it. So my homework assignments will guide you through it in a way where you can consume it in a sensible way, because I can't really expect you to consume all of it as just one big chunk like that. At the very least, I want you to do all the reading of the language learning just so you know what it can do. Even if you read something like, what is that feature? I didn't really get that language feature. At least you'll know that there's such a language feature out there. And then when I mention in the lecture, you're like, oh, that's what that is. And then you will have 5 programming assignments. And these programming assignments build on each other. So assignment 1, which is going to go out on Wednesday, will be due next Wednesday, and then assignment 2 is going to go out next Wednesday. It will build on assignment number 1. So if you're late turning in assignment 1, oh, now you're late doing assignment 2. It's going to cascade. And same thing, 3, 4, and 5 all build on each other. Like I say, they're mostly week-long assignments. I'm kind of thinking maybe for assignment 3, I might give you an extra few days, so maybe that's 10-day, kind of a thing. But I'll play it by ear. We'll have to see how it goes. And then the final project. So the last 3 weeks, I will give you no homework assignments, and you'll spend entirety of your time on the final project. And your final project, you get to choose what it is. You can do anything you want. There is a process whereby you run it by us so we can look at it and tell you, no, you're never going to get enough points to pass this class with that simple idea or whatever. And so you can get some guidance from us doing that. Yeah, question?
I haven't joined the course formally, so just to be sure, is the final project individual or is it a group?
Yeah, so the question here is the final project an individual only? Because all the homework stuff is individual only. And the final project is generally individual only, although I will allow, under certain circumstances, teams of 2. So when you get on Canvas and you read the course description, it explains all the rules for that, but there are rules. But no more than 2. No more than 2. And it's actually more work to do this final project in a team of 2 than it is to have 2 individuals do it. And so that's explained in the document as well. All right, so let's get started, and we're going to build this application together. But before we can get started with the app we're going to build, we got to learn a little bit about Xcode and a little bit about SwiftUI, the heart of SwiftUI. That's what we're going to learn today, its heart. So let's go over to Xcode. How many of you have done assignment 0? Oh, most of you. Okay, great. So if you've done assignment 0, then you have Xcode. If not, no problem. You're just going to download this thing from the App Store. Now, Xcode, when you launch it, has this splash screen, and on the right is all the projects that you've ever worked on. And if you've never worked on Xcode, this is empty like this. But as you go along the quarter and you're doing your homework assignments, you will see this in here. And then on the right is just 3 ways of creating a project, either creating a new one, cloning one from a GitHub repository, or opening an existing project on disk. So we're obviously going to be creating our first new project here. You can also do it with the File menu, as I said in assignment 0. Go down here, say File, New Project. When you do this, it puts up this little thing. And what this is asking you is, what template do you want to get started here? And there are actually a ton of templates because there's a lot of different kinds of apps that you can build. Different iOS apps, Mac OS apps, watchOS apps, Apple TV apps, Vision apps, etc. And we're going to start First of all, with a multi-platform app, because we want our app to work on iPhone, and then it's going to work on iPad, and then it's going to work on Mac OS, right? So it's multi-platform. And we're going to pick this one app in the upper left, which is the basic app. And why are we choosing that? Because we're just getting started. We're just learning. All those other things, I would have to teach you other stuff to use those, build those other kinds of apps. Now it's saying, where do you want to store this thing? And this is the most important step of this whole thing, okay? Because you want to put it in the directory you cloned from GitHub. So if you're watching this lecture and you haven't done assignment 0, now you definitely want to pause and go do assignment 0, because you need to clone a directory out of your repository in GitHub, and then you want to put this in there. Now, one way to really check and make sure you're doing the right thing is this right down here. You see where it says create Git repository on my Mac? That should be grayed out. If you've picked the thing you cloned, then the repository is in GitHub, so it won't even offer you this. So this is the thing I cloned. I'm going to create it. I did assignment 0. Oh, you briefly saw it get created right there. And this is it. So let's go ahead and make this nice and big so we can see what's going on here. And I'm going to give you a tour of Xcode here in a big spiral. Okay, I'm going to start in the upper left. I'm going to spiral around the edges until I get to the middle. And the middle is all this code in here. So let's start with the spiral. Upper left corner is this button right here. This button hides and shows this grayish blue thing on the left. That thing is called the navigator. It's called the navigator because it lets you navigate your application in lots of different ways. For example, this is, you can see it's on the leftmost tab right up here. In here. This is navigating by files, basically. So we're seeing a file here, ContentView. It's a Swift file. You see that little orange Swift bird there? This is a Swift file, and that's what this is right here. And then here's another Swift file. This is our main program right here. And here is an interesting one. This is our assets. This is all of our media, our JPEG files, our sound files, our colors, our app icon is here. If I click here, we don't have an app icon, but that's where it would go, etc. So that's what this assets thing is. And you can even click on this top thing. That's your project itself. This project has a lot of settings. I mean, every one of these tabs has a lot of stuff in here. And the great news is about all of these things is that Xcode takes care of them for you. Okay, there's almost nothing you need to do in here. I don't even know if we'll ever go in here in the next 6 or 7 weeks because Xcode is so good at automatically managing things. But you could do things in here. Look in this first one, you see right there, it says supported destinations, and here they are. We know we're not going to do Apple Vision, so I could remove that from the list if I wanted. I don't have to, but I could. And then we're going to build, for example, for iOS 18.2, we want to build for the latest thing because we want to learn the latest features in SwiftUI and all that. But we're not going to go here very much. Now, there's other ways we can navigate. Here's the navigation to our repositories, like our GitHub repository up there. Here is searching. Navigate by searching. Find and replace. Don't forget there's find and replace. And this is project-wide find and replace. There's find and replace in a file, of course, but then there's also this project-wide one. There's your breakpoints over here. This is kind of a cool one. This is all the output from all your previous builds. So you might run your app and it crashes with some warning message, and then you think you fix it and you run it again and it has a different message and you're like, what was that message that was referred before? And then you can go back and see your previous builds, which is really kind of cool. So this thing is the navigator, the project navigator. There's actually a better way to navigate through the files, which I'm going to get to when we come around the next time of the spiral. So we usually leave this thing closed. All right, what's the next thing in our spiral? Oh, it's this button right here. This is the play button. This is how you run your application. Now, where is it going to run it? Well, it depends on what's selected here in the middle. So right now, it's my Mac is selected. So it's going to run my app, this Hello World app that it built for us here, on my Mac as a Mac app, which is kind of cool. But I told you we're going to start running it on an iPhone. We're going to build our app on an iPhone first. So I'm going down to the bottom here where it has simulators. See where it says iOS simulators? So I've got iPad simulators of all the various kinds, an iPhone simulator right there, and there's even other ones like iPhone 15s and 14s that you can get those from manage run destinations. But I'm going to pick iPhone 16 to run my app. Notice it changed on screen here. It should be an iPhone as well. And I'm going to hit run. I'm going to hit this play button. Now watch what happens. It's going to actually launch another app. This is the iOS simulator. And it ran our app. There it is. Hello world. Now, this is cooler than you think, because not only did it go and run our Hello World app, but this is a full iPhone that can be simulated. You can go into settings and set some settings. You maybe could go over to Mail or to Calendar. And why do you need this simulator to have all those things simulated? Well, because your app might interact with the calendar, or it might interact with Mail. And so you need your app to have this in the simulator. Now, the other thing is, of course, you could run your app on your device. If you take a USB cord and jam it in there, hook it up to your phone, then back over here, where we have our choices, one of the choices will be your phone. And then you just click play, and it'll run it on your phone. It's as simple as that. It's really, they have made it so simple. It used to be much more of a chore to make all that work, but now it's just all completely seamless. It's even possible, if your Mac and your iPhone are on the same Wi-Fi network, you can do it wireless. You don't even need to plug with a USB. It'll run it on your phone using wireless. It's really very convenient. And then you can see once I ran, look, this little square appeared to the left of it, which is stop, to stop my simulation running. And you can see over here it was telling us as we were running on iPhone. Now it says finished running. That's your status bar. It just tells you what's going on when you're compiling, et cetera. It'll tell you that. All right. Let's keep going around in our spiral. This little guy right here is incredible. Unfortunately, we will not be doing anything with it in this class. This is Xcode Cloud. Let's say you build an app and you're about ready to ship it out to the App Store. Well, you want to test that thing on every single device on the planet that you want to support, right? All versions of iPhones, iPads, different versions of the operating system, et cetera. That's impossible for you to do as an individual developer, or even as a company. What, are you going to have 100 iPhones lined up on the table and you're hooked? No, you can't do it. So what Xcode Cloud lets you do is upload your app to a server, and it runs it on a whole bunch of platforms, and then gives you the feedback, all the ones that crashed, things that didn't work. And again, you've got this great testing infrastructure, so it can tell you everything, what's going on with your app. So that's what Xcode Cloud is about. Obviously, we don't do it here because we're not putting it on the App Store. We're never getting to that level, but that's what it's about. This little beauty, this plus, this is a hidden wonder right here. If you click on that, this is the library. The library has a whole bunch of nice things you can look up as you're developing your app. This is on the second tab right here, this little tab, which is our view modifiers. I'm going to talk about view modifiers at the beginning of Wednesday's lecture, but view modifiers are at the heart of what we're building. There's two things at the heart of SwiftUI. One is views, and the other one is view modifiers. And if you look through this list of view modifiers, there are a lot of them, hundreds of these things. So mastering SwiftUI is eventually learning all these view modifiers, believe it or not, or at least the vast majority of them. But in the meantime, you can kind of come here to the library and search for them. Maybe I'll search for things that have to do with fonts. Here's a bunch of view modifiers that have to do with font. Even that, there's a ton of them, but here's the font view modifier. And you can see it's got the documentation there for you to tell you about it. And same thing with the other heart of it, which is views. This is buttons and color pickers and date pickers and disclosure group. These are all views, things that we build our UI out of in iOS. And I'm going to teach you all about views today. Today is about views. But there's more in the library. There's also code snippets. Here, if you search for things, you can, like here I search for variable, var, and it's showing me a whole bunch of code snippets that have to do with variables, like this is a code snippet for the declaration of a variable. Variable name equals a value. Or here is a computed variable, which we're going to see going on today. And you can double click here, and it'll put that in your code. And then see the gray things, you can tab to them and fill them in. So that's kind of cool. Part of it. And then in addition to code snippets, we have colors and images. These are things in your asset library. Remember I told you about that assets thing over there? That's these in there. You can name them, look, search for them, etc. And then this one is really cool, symbols. Swift has thousands, many, many hundreds of symbols that you can use on your buttons and to decorate your UI and all that stuff. And they're all listed here. Now, you can search for them here. Like, this is Stanford. Let's search for tree. Oh, there's a tree. A nice little tree. Doesn't look like the Stanford tree, but it is a tree. You can search from here. But there's actually another app called SF Symbols, which you can get by going, I'll post this on Ed Discussion, but you go to developer.apple.com. And right there on the home page, there'll be like a downloads thing, and you can download SF Symbols. So SF Symbols shows you all these symbols, but much more searchable, and you can see all them in color, because these are all multicolor things, etc. But we end up using these symbols quite a lot. Now, why does Apple go to the trouble of making these hundreds of symbols? Well, because it wants symbols for certain activities to be the same in every app. So that when I see a symbol, it's like, oh, I know what that does. I saw that in another app, and it does that thing. All right, let's keep going around our spiral and click on this one. This is similar to the other side. It's opened up a little pane. This is the inspector. And this pane is inspecting what's selected on the left. So if I click on this tab, this is the file it's in. See, it says full path. It's even telling whether this file is included when you build this app. CodeBreaker. And there's other things too, though, like if I pick this hello world line of code, then if I go to the rightmost tab, this is things about that selected line, like what font is it? What color is this thing? And I can actually change it here, and it's going to change the code. So I want you to keep an eye on the text hello world over there, and I'm going to pick this font thing, and I'm going to change it to be a large title font. Okay, ready? I clicked, and it added a line of code. And let's make it so we can see. If I delete this line of code from here, then the inspector will be back to not showing it. See, so hello world's so small we can't even see. Large title. We'll continue this, and it gets bigger. This is kind of a way to write code without typing in code. Now, why would you ever want this on the right? Well, in this class, you probably don't want it, because I'm going to teach you to code, so you're going to be writing the code on the left. But what if you were a localizer making this app work in a different language? Or what if you're a UI designer and you're trying to pick the right font sizes and all that stuff, but you're not a coder? Here you can come in, do that. It's going to change the code. Then you're going to use the GitHub or something to merge it back in with the coders who are writing the functionality. And so, in a way, it makes it so that non-coders can contribute to the coding process. Does that make sense? So localization, graphics design, those are two good examples. In this class, you're not going to use it. So this is mostly going to be closed, okay, for this class, which is good because we want the screen real estate. Okay, let's keep going in our spiral. We're going to go down to here, this little area down here. See that? Now, this appeared when we ran the simulator. And why did it appear? Because these little lines, messages, came out on the console. So this right pane, and you can close this right pane with this button, open it, and close the left pane with this button. This right pane is the console. And we will do a lot of early debugging in this class by printing to the console. Printing to the console, especially in a reactive UI like this, really nice, because you can just see what's going on without interrupting the UI drawing itself. So we'll do a lot of printing to the console. And you're going to see SwiftUI putting a lot of stuff on the console too, like this. On the left, that's the debugger. When we start debugging and looking at variables, it's going to be showing the state of all the variables in this backtrace in that window right there. The debugger also includes something from here, the navigator. When you start doing debugging up here, the backtrace of a crash will appear here. So you'll be able to see the full backtrace and click on levels of the backtrace and see the variables down here in the left. We usually have this closed as well, because if we run in the simulator and it crashes, it'll bring that up, just like it brings up the navigator when it crashes. All right, keep going around. We're going to go around up to here. So we're back up to the top, but not all the way to the top. We're talking about these two lines right here. This guy is kind of a quick way to go to recent files, for example, files that you've recently been editing. Also, locally modified files. So once we check this in to GitHub, then if we make an edit after that, it'll be a locally modified file, right? So we can quickly go to it here. And it has a bunch of other stuff I'm not going to talk about, but it's kind of a quick access menu, this thing. The next thing up here is back and forward. So it goes back to the last thing you looked at and forward. It's like a browser's back and forward button. And then right next to it is tabs. You see this is tabs, and these tabs will build up as you go around to different files. Just again, like a browser, tabs in a browser. And then this is really cool. This is our path to what is selected here. So I've made a selection there in blue. It's inside that thing called body. See the word body right there? So it's saying, oh yeah, you're in body, which is in ContentView, which is in the folder CodeBreaker, which is in the project CodeBreaker. Right? So it's showing you the path. And if I clicked up here on the content view, now it says I'm in the content view. And I can actually navigate to things by picking here. See, I'm going over to our main program, going back to our content view. So this is both navigation and telling you where you are. So that's mostly how we navigate, rather than bringing out this big, heavy thing over here to use a lot of screen real estate, etc. We tend to just use this path to navigate, or our tabs. Make sense? All right, let's go over here. We got these three buttons. These three buttons basically are configuring how your UI looks over here. And before I show you this first one, I'm going to commit my code to GitHub. Okay? So I'm just going to go up here, integrate, commit. And this is what we saw in assignment 0. You can see it's got everything here because I haven't committed yet. I've never committed. So I'm going to call this my new project commit. And I need to stage everything. So I'm staging all the files. Again, you could stage only some things, but if you stage some things, you might check something in that doesn't work, right? Because you had two files that kind of depended on each other, and you only think so. Be a little careful of that. I tend to try and stage all. And then I'm just going to hit commit. It commits it. That didn't do anything in GitHub yet. That has just committed those changes to my repository. And if I wanted to go up to GitHub, I'm going to then say push. Push might as well be called submit my assignment, because it's going to put it up on GitHub. And again, we want this main right here, and I'm going to hit push, and it pushed it up there, and so now it's up in GitHub. And I can go to github.com and see it there and see what I've submitted. It's really, really great. So now let's go and take a look at this again, and look at this little, close this, and look at this little arrow. You see this little double arrow? That is doing code review. That is showing you the changes between what's on your last commit and what you've done so far. Right now, they're the same. There's no changes. But what if I went in here and got rid of that font large title thing? Now look, little gray thing saying, oh, you deleted that. This is an awesome way before you do a commit to say, what have I actually changed? So that's what this little guy up here is. This one right here is for opening and closing windows. Like you see this big version of an iPhone right here, which we haven't even talked about yet. You can make that go away by saying show editor only. If you don't want to be seeing that, you can do show editor only, or you can bring it back by saying canvas. This thing is called, by the way, our preview canvas. You can also show some other things, like when you do your comparison, you could do it inline instead of having two side-by-sides like that. You also have this mini map, which is kind of fun. This is a miniature version of your entire file, you see? And now I only have enough code for it to fit at the very top. But what if this was really long? Then I could use this thing to navigate around in my file. So that's kind of a fun thing there. So that's the mini map. And this last one here, this little plus, adds another pane. So now I have two things going. And for example, on this side, maybe I'll put my app, my main program. And on this side, I'll put my content view. And it even has its preview down there below. And you can have as many of these as you want. I only have two, but I'm allowed to add another one over here, and I can close them, etc. The little trick, if you go over to the navigator and you go option click, it'll open up another one with that. So if you're the kind of person you like the navigator open, option click in the navigator, kind of a cool way to open a second window there. Let's go back to showing our content view. So we're still making our spiral. We got these three buttons up here. Now I'm going down to the preview right here. So this preview is amazing. Okay, it's even more amazing, in my opinion, than the simulator. And let me make it so that its size is good here. It's showing me what is going on here on the left-hand side in real time. So this is my UI, this code over here, essentially being compiled and run instantly. So watch this. See, it says hello world. What What if I change this to hello CS? Look, it's happening on the right. 193p. You see? It's actually compiling and running my code in real time. This is how you're going to be doing all your development. Now, of course, if you make a big change, copy and paste a big piece of code in there, or you have a syntax error where it can't compile it, then this thing on the right might pause. It might even crash and then pause. Or when you run the simulator, it will definitely pause. Or if you build your code, which you almost never do build because it's building it for you all the time. But if you build your code, it will pause. And that's what we saw before. So let me do that. Build. See that preview paused? And if you just click continue, it'll start running again. Now, you can have it in this run mode all the time, or you can switch it to this mode. You see this little switch down here? That turns it to select mode, selection mode. And here, when you select something in here, it's going to select it in the code. This is great when you have a big complicated UI and you're like, where is the code for that button? And you go and click on it and it'll take you right to it. And vice versa. If I go here and say, where is this text field? Oh, there it is right there. You sometimes will go in there, but it's more like a discovery thing to find things in there. And then these buttons over here, we're not going to show them now, but those are for things like, show me what my UI looks like in dark mode, or show me what it looks like in landscape instead of portraits, or show me what it looks like when the fonts are really big. When you get old like me, you want the fonts on your phone big. Your app still wants to look good, doesn't want all the wrapping of text to look terrible. We can do all that so we can see in the preview under those circumstances as well, but we'll show that stuff to you later. All right, so we're going to leave this in run mode the vast majority of the time. And that's it. Yes, question? How is this different than running in the simulator? You know, it's actually not that different. Probably the same code that runs in a simulator is somewhere running in the background here kind of really quickly and showing this UI. I don't think it's that different, but there are certain things that don't work totally right in the preview, like sophisticated animation. We're going to do animation in a couple weeks. You're going to see some of the animation doesn't quite work right in the preview. Some stuff doesn't quite work right in the simulator, and you have to go all the way to device to really test things. But I'm going to say 95% of the stuff works here, 99% of the stuff works in the simulator, and then 100%, if it's going to work on the device. Okay, so they're not perfect replicas of each other. But the main difference is, though, that it's on the screen at all times. That's the main difference. You used to have to, before they had this, you'd have the simulator, you'd have it up on screen at the same time, right, side by side, but it used up a lot of screen row space, too, and it couldn't easily be closed. So this is a far superior. And plus, you'd have to hit run every time, whereas here you don't have to ever hit run. Any questions about Xcode? That was kind of the quick tour. I mean, look, let's look at Xcode's menus, shall we? Look at all this. I didn't even tell you about, except for this thing, I didn't tell you about these things. There are a lot of stuff in Xcode, and plus there's settings. Don't forget about all these settings. We'll learn most of this stuff by doing. I'd take the whole lecture today if I had to show you all of that stuff. So now we know about Xcode. We're going to go talk about this code right here. This is really the end of our spiral, is to get to here and talk about this. And I'm going to talk about every single character on here and what it does. And I'm going to start down here. This hashtag or # preview, it's just saying what to show on the right here. This is our preview canvas, and that little code is saying what to show here. Well, right now, it's saying show the content view. Well, what's the content view? That's this. That's why it's showing all this. And this is normally what your preview looks like. It just has the name of the thing that is in this file, but you can change it to anything you want. And you'll see me do that on Wednesday, where I add things to make it so it's showing my view more appropriately so I can see what's going on. Now, this preview canvas is not UI testing. There's a UI testing framework for that. But it is UI standard check, right? Take a look at my UI. It's like, oh, yeah, that looks like I think it's supposed to look. All right, let's go up to the top. This is a comment. This is what comments look like in Swift // You can also do /* and then end with */ just like in other languages. Nothing special there. This, you probably know what this is, right? You've seen include or # import in other languages. This is basically saying my code here wants to use somebody else's code out there. And Swift has a really powerful mechanism for doing modules and packages, and they package all of the SwiftUI stuff, so buttons and windows and all that stuff, into one package, SwiftUI. Now, you might think, well, I'm always going to import SwiftUI in this class, but that's not true, because when we do the back end of our app, for our CodeBreaker game, the actual playing of the game, the logic that plays the game, that will not be in the UI. That will be separated from the UI. So there we will import something called Foundation. You'll see that. Or maybe SwiftUI Core, which is some of the core things in SwiftUI, like colors and things like that. So we're not always doing that. And then there's other things we're going to import, like when we do the database thing, we'll import Swift data that I mentioned before. So import, we don't use it a lot. It's usually SwiftUI, but sometimes we will. All right, next word, struct. So struct is a keyword that says that we are building a struct here. A struct is the most important data construction mechanism in all of Swift. Now, other languages have structs. Probably almost every language has a struct, right? C has structs. In other languages, structs are usually containers of variables, right? You got a struct, it's got some variables in it. And that's true in Swift as well. However, structs are much more powerful in Swift than that. Structs have functions, for example. You might be starting to think, wow, this sounds like a class, right? A class is like a struct that has functions, but this is most definitely not a class. Swift has a keyword called class, and a class in Swift is a collection of variables and function, but a struct, which is also a collection of variables and functions, is a different thing. I'm not even going to talk to you about class for 3 or 4 weeks. Now, we will use a class in this course, but not for a while. So right now we're focused on structs. Everything we build in our UI pretty much is a struct. And this word ContentView is just its name, just the name of this struct. So that's how you create a struct and its name. Why is this called ContentView, by the way? Well, because this is just template code. It doesn't know what we're building. So this is basically saying that this struct is a view of your content of your app. So that's just a completely generic term right there. We will be renaming this post-haste, probably on Monday, to be something like CodeBreaker View. Now, this right here, super duper important. This means that this struct called ContentView behaves like a view. That's what :view means. It behaves like a view. This is not view as its superclass. This is not object-oriented programming, okay? There's no inheritance going on at all. In fact, structs have no inheritance. That's one of the things that makes them different than a class. No inheritance in a struct. So this behaves like a view. Well, what is a view? A view is what we call a protocol. And you heard me say earlier that Swift is a protocol-oriented language. Well, you're seeing it right here. And what is a protocol? A protocol is a description of behavior, specifically vars and funcs, things that want to behave like a view get or have to have. And if we looked at a view's definition, any protocol's definition, we would see that it's just a list of functions with no bodies, just the names of the functions, and vars with no values assigned to them. That's what it would be. So when we say a struct behaves like a view, we're saying that it has all the behavior of view, but we're also might be saying that we have to do something as a struct if we want to behave like a view. So in other words, when you say you behave like a protocol, it's a double-edged sword, okay, or at least a two-sided coin. One side is you have to do something to behave like a view, okay? If you say you behave like a view, well, then you better behave like a view, right? So it might be something you have to do. But the flip side of the coin is, if you say you behave like a view and you do that thing you're supposed to do, then you get all the rest of the things that a view knows how to do. And I already showed you in library, all those view modifiers, those are all functions in view. So you get hundreds of functions if you say you behave like a view. But of course, you have to do something to behave like a view. It doesn't come for free. We have some responsibilities in the world, and the responsibility that you have to do to be a view is to implement this variable. If you implement this one variable, then you are behaving like a view, and then you get hundreds of other functions on your struct for free. They just come for free. So what is going on here with this variable? First, let's talk a little bit about what a variable is or what its syntax is, at least. In Swift, it's just simple. The word var is keyword for variable, the name of the variable, like I, and then colon, its type. Okay? So that's how you declare a variable. Var, name of it, colon, type. Now this colon int right here is different than the colon view above. The colon view above, view is a protocol. So the colon view above means behaves like. Okay, colon view, it behaves like a view. That's what that means. This means it is an int. An int is a concrete type. It's an actual type. It's got storage, obviously some integer value in there. So I guess you could say that that var I behaves like an int. Well, yeah, because it is an int. Int is a concrete type. And we can have lots of other kinds of vars. How about var a string? We have a var that's a string. And int and string are not some sort of built-in thing. They're just structs. Everything is a struct, pretty much, in Swift. Unless it's a class, which, again, I'll talk about in a few weeks. Everything is a struct. So int is a struct, string is a struct. They're struct, or they're protocols, like view is a protocol. So that's what it looks like to declare a variable. Now, you probably noticed that the AI, when I started to type this, it tried to put equals 0 there. You see that? I didn't do that. It did that. One thing in Xcode, if you go into settings, I'll show you this, but you might as well do it. If you go to settings here, and you go to text editing, and you go to editing, you'll see here it's got this suggest completions while typing and predictive code completion. It has a whole AI engine that it'll actually download to your computer to kind of guess what you want to say. And it's not bad. I mean, you probably use ChatGPT to do coding or something. It's not bad. And so this one's a simple example of it, but I typed var I int, and so it says, oh, well, do you want to set it to 0? So I'll say, sure, give me that 0. And when you hit tab, it fills it in. So this variable is getting an initial value. Now here's an important thing to understand about Swift variables. Actually, two important things right at the same time. One is Swift variables always have a type. Swift is what's called a strongly typed language. It's very different than like Python, where it's like you have var I, and it's like, is that a string? Is that a number? I don't know until I put something in it what it actually is. Swift, no way. Everything has to have very explicitly have a type, a specific type. There's no floating around in Swift. And number two, all Swift variables must have a value at all times. You're not allowed to have a variable. It's like, what is the value of this? I don't know. It's nothing. It always has to have a value.
There's no concept of none or null.
So the question is, so is there no concept of none or null or nil? Oh, yes, there is in Swift. Very important, and I'm going to show you that on Monday, because it's a very important type, but it is a type. It's called optional. The type is called optional. It's not nothingness. It's a type. I said that these vars always have to have a value, but you don't always have to say equals here. That's one way to give them a value. The other way is if you don't specify one, like var s string right there, then when someone creates a content view, they have to give you that value. In other words, it's not possible to create a content view struct here with that s like that unless the person who creates it gives me the value for s. Because s can't not have a value. So either I have to initialize it like this, or I have to give it a value. There's another way, which is that we can have initializers. And you're probably used to this in other languages. C++ has constructors and things like that. Of course, there are special functions that we can add to a struct that initialize the variables to certain values. That's another way of doing it as well. Okay? So that's variables. That's our quick thing about variables there. So let's get back to this variable. Now, this variable's type is kind of kooky. Okay, some view, it's got a keyword in there and then a protocol. And I told you that these variables have to basically be concrete types. But we know view is just a protocol. It's not a concrete type. It's not a thing. It's just a description of behavior. So what does some view mean right there? Well, some view means this has to be a concrete type, but it has to be some view. Okay, it has to behave like a view. But even more than that, the actual concrete type here is going to be determined from this code. This variable, var body is what we call a computed property. Variables, we sometimes call them properties because they're a property of a struct. This thing is computed, and that means every single time someone asks what the value of this var is, it runs that code. Every single time, over and over and over, every single time. Now you might think, wow, that sounds pretty inefficient. I got to run code every time to figure the value of this thing. But Swift is super efficient about not calling this unless something that is inside of it might have changed. So don't worry about the efficiency at all here. Now, this idea of having a variable whose value is computed like that is very common. We're going to do it all over the place, not just for some view kind of a thing, but all the time. It's just very, very, very common to do. And you can kind of look at it as kind of like a function that has no arguments, that only has a return value. I guess you can think of it that way if you want. I think that's fair to think of it that way. But the real key about this computed property is that we're going to look in here and see what this evaluates to, what it is, and then the compiler is going to replace some view with that concrete type. Some view is magic from the compiler that will look in there and replace it with the actual concrete type, which means that whatever's in there has to evaluate to a specific single concrete type. And I'm going to show you how it does that magic in a second here. But before I do that, I want to just quickly talk about views in general, because inside here, I'm going to clean this up and make it a little less sophisticated here. We got to look inside there and see that there's a whole bunch of views in there. This right here is a view. This is a struct that behaves like a view. This is also a struct that behaves like a view, and this is a struct that behaves like a view. So what do structs that behave like a view do? Well, they're rectangular areas on the screen that draw. That's what a view is. And also those views can receive multi-touch events, swipes and taps, things like that. That's what a view is. And it's kind of weird that to behave like a view, you have to have a var that returns some other view, right? Because that's what it says right there. My responsibility, if I said I want to behave like a view, is I have to implement var body some view. That basically means I have to implement a var that returns some other view. So how does that make any sense? We're creating image here. When we create a struct, we give arguments to it in parentheses. You see this? Text, give it arguments. And like some take no arguments. Like if I put a circle in here, okay, big circle, no arguments. Sometimes the arguments have names, system name right there. See that system name globe? But sometimes they don't, like text right here. You see that? So that's how we create structs. We just, their name, and then the arguments it takes to create them. And sometimes those arguments are like that var s string. They're uninitialized variables that you have to initialize, right? But other times they're arguments to a constructor or initializer. But notice that this guy, he doesn't have any. Okay, what kind of, what's going on with that struct? Okay, that is a wacko struct right there. VStack has no parentheses after it. And it also has a curly brace thing after it. So that is just ridiculous. So let's take a pause here and talk a little bit about views, because I want to introduce some analogous terminology that you can use to think about views, so that when I'm talking about them, I'm going to use this analogy and you're going to be like, oh, I see what that is. I see what that view is. I understand how that view works. Okay? And the analogy we're going to draw is Legos. Okay? Everybody loves Lego. I've got this Lego set right here. It is, I can't tip it up or it'll all fall out, maybe. There we go. It's a city Lego. This is Emergency Vehicles Headquarters. 706 pieces in here. Okay? And everyone here has played Lego, I hope. Okay, if not, you can leave now. But no, okay. So Legos, so most Legos here, I'm going to put these Legos out here maybe so that the camera can get them. You can look them inside. Most Legos kind of look like these little pieces. You can zoom in there maybe. Let me zoom in. And then maybe we'll put them up here. I don't know if we can do that. We'll put it up here even. I don't know. Anyway, for those of you who are in the building, I'll pick one up. Here's a Lego, right? This is kind of one piece of Lego. And there's another. This is like a normal Lego brick. It's kind of a funny color, but it's Lego. This is what we think of when we think of what's a Lego. And there are all kinds of weird Legos there. Like this one right here. I don't even know what that is. Some kind of flower or something? I don't know. And so you can probably quickly go from here to understand my analogy. It's like, of course, this text right here, am I still up here? Yes. This text or this image, they're like Lego bricks, or this circle. Right? They're kind of fundamental building blocks, and I'm going to put them things together to build things, okay? All right, good. Good start, okay? But we're going to push this Lego analogy a little bit further, okay? And we're going to do it with this guy right here. See him? This is a little helicopter. This is what I'm going to call a helicopter Lego. So I'm going to extend my definition of Lego to not just include bricks, but completed things. This is now a Lego. It's a helicopter Lego, right? And this Lego, this helicopter Lego, is actually made out of other Legos, like a rotor Lego and skids Legos. Here's 3 Legos I have in my hand, and I'll put them together to make another Lego, which is a helicopter Lego. All right? So everyone cool with my extending this analogy to say that when you put things together, now you have a Lego. Okay? I'm not done yet, though. So this helicopter Lego right here, if it'll stay there, that is like this guy. ContentView, right? ContentView is obviously, here it is, over on the side there. It's obviously made out of those other Legos. And I'm going to say that ContentView is a Lego because I'm going to say that Legos are views, okay? So Legos bricks are like text and image and circle. Lego, like a helicopter, is like ContentView. Everybody cool with my analogy? Okay, now I'm really going to go crazy on you because if you get a Lego set like this, it doesn't have 706 pieces just strewn about in here, and you got to like look on the outside to figure out how to put it together. Okay, it's not a jigsaw puzzle. It's Lego. And so the Lego actually comes in little bags. See, this is bag number 2, bag number 3, okay? And it also has instruction manuals. Yay, because we couldn't build these things without that. Right, here's 3. This is for building this, you know, a medical building or something. We got an ambulance, police car. Okay, there's a book for all of those things in here. So I'm going to say that a bag of Lego is a Lego. Okay, so if you accept this from me, then you're going to be in good shape in this class, all right? So this is a Lego. So just like I put those Legos there, I'm going to put that there. That's a Lego. Okay? It's a bag of Lego. That's the thing. So you're going to hear me saying later in this course, oh, this is a bag of Lego view. Okay? And that's because we're going to define our Lego analogy that a bag full like that is itself a Lego. Then I'm going to go even farther and take these instructions. Here's the instructions for the skids. Okay? Here's the instructions for the rotor. What am I going to say this is? Yeah, it's a Lego. Okay, this is a Lego as well. Okay? So we have 4 kinds of Legos in the world. We got bricks, we got helicopters, which are constructed Legos, we got bags of Lego, and we got instruction manual page Legos. They're all Legos. Okay? Now, where are those up here? Well, VStack right here is an instruction manual page Lego. Because a VStack is a view, but its only purpose in life is to put other Legos together. In this case, it stacks them vertically. That's why we have our 3 things there stacked vertically. And where's our bag of Lego? Right here. That is a bag of Lego. So that little curly brace thing right there is actually returning to us a view. It's called a tuple view. You don't care about that, and you're never going to type the word tuple view in. But that's what it's doing. It's returning a tuple view, which is a view, but it's a view that is purely a bag of Lego. Holds other views. So that's my analogy. So when you hear me say bag of Lego view, I'm talking about what's selected here. When you hear me say instruction manual view, I'm talking about something like VStack. If I say helicopter view, I'm talking about something like ContentView that we build. And then, of course, Legos like image, text, and circles are like Lego bricks. Now that we have this terminology, we're armed with it, let's break down this really weird code around VStack. Because, as we said, VStack has no parentheses after there, and it has this weird curly brace going on here. And then, while we're at it, let's understand why var body some view is the thing we're required to do if we want to behave like a view, because they kind of go together. Let's look at the actual arguments of VStack. If I go option click on something, option click, it will bring up documentation for that thing. And here's the documentation for VStack. Now, we don't know enough yet to fully understand what's going on here, but we know quite a bit. And we can see here that when you initialize a VStack, this init is the constructor function I was talking about, but forget that. It has 3 arguments. Look, alignment, horizontal alignment, spacing, which is some floating point number, content colon, that. Okay? So let's explore these 3 things and see what is going on. Let's put these 3 arguments out here. Okay, let's start with alignment. So alignment dot center. Now that happens to be the default dot center. That's why they're centered. You see them up there, centered? I can change it though. How about alignment leading? Oh, they slammed over to the left side. Now, when we do alignment, horizontal alignment like this, we don't use left and right. We use leading and trailing. Anyone want to say why we use leading and trailing? Yeah? Exactly, because some languages, the text flows left to right, and some from right to left, like Hebrew and Arabic flow right to left, and English and other Western languages, they left to right. And we want all of our UI to flow in the same direction that all our text is flowing, so that's why we do leading and trailing. All right, the other one was spacing. Spacing. Okay, let's try 100. See how it spread them out? Let's try 10, close them down, or 1. Really small. And the default there is surprising default. The default is the right amount of spacing for this platform. So on the Apple Watch, it's probably going to be quite small. But on an iPhone, it's going to be pretty good size. You know, in Vision OS, maybe it depends on the context you're in. It could be quite big. So spacing defaults to the right thing. So you should use the default as much as you can for spacing so you get the right thing most of the time. And then the third argument, let's put it back up again so we can remind ourselves, was content colon, and then this thing. So let's type it. Ready? Comma, content colon. Oh, it's even telling me right there. See that? It's saying this is the type of it, right underneath. What is that type? Anyone want to guess what that type, parentheses, arrow, context, what is that type? Yeah? Function. A function. Exactly. A functional programmer right here, maybe. It's a function. And this is what we mean when we say Swift is a functional programming language. We are passing functions to other functions, or in this case to the creation of the VStack, to do the behavior we want that function to do. Now, what is that content thing that it is returning? Let's take a look over here. VStack. It says that that content thing is where content behaves like a view. Now, we're not going to talk about where clauses and all this @sign frozen stuff down there, but you can see that struct VStack down there, this area right here, it's saying struct VStack has this content where content behaves like a view. So this function up here that content is going to return has to be a function that returns something that behaves like a view. That's what that parentheses arrow content made. And the parentheses being empty means what? That this function takes no arguments. So I'm going to create a function that takes no arguments and returns something that behaves like a view. So let's see what it looks like to create a function in Swift. We've never created a function before. Let's do it. Func is the keyword. And now you just put the name of it. I'm going to call this greetings. And then the arguments. I said I was going to create a function that took no arguments, so open parentheses, close parentheses means no arguments. But if I had arguments in here, you know, I could pass an integer in there or whatever. And we'll learn a little bit how I create arguments that have names, like system name, image system name versus not. In this case, no arguments. And then you say returns. That's what the arrow means. That's what this function returns. And I'm going to have mine return a text. And then I'm going to have it return a text that says greetings. Does everyone agree that this is a function that takes no arguments and returns something that behaves like a view? Because we know a text behaves like a view, right? Well, since I have such a function, look up here. I can say content greetings, and then just get rid of all the rest of this junk here. And now I've created a VStack that has a content which is greetings. You see it's showing greetings right there. Because I gave it what it wanted, a function that took no arguments and returned a view. Now, of course, I don't want just a text. I want other things too here. I want, like, let's put our image system name globe back, for example. And then maybe also put a circle in here. Circle, but I better not put return in the middle of that. So let's just take that out of there. Okay, so this is kind of what I had before. I had these three things, right? Image, text, and circle. Well, this generates a massive amount of errors. Look at all those errors. Result of image not used, missing return, because of course I took that return away, so I don't have return in there. So what the heck, what am I going to do here? Well, what I really want is for this thing to not return a text. I want it to return a bag of Lego view, right? So how do I make this thing into a thing that returns a bag of Lego view? Well, I'm going to put a little magic little statement on here, @ViewBuilder. So if you put @ViewBuilder on a func or on a var, it will interpret the stuff inside of it as a list of views and bag them up and put them in a bag of Lego and return that. But now it still has an error here because I said my greetings returned a text. But that's clearly not what it's returning now. It's returning a bag of Lego view of some sort. And what is the type of a bag of Lego view? Well, it's actually telling me in this error. You see it says cannot convert return expression of type tuple view image. Let's type it. Let's make that be my return type. So let's see, it's tuple view with an image, a text, and a circle. Let's see if that works. Well, it works. No errors. So that is the concrete type, tuple view. Tuple view is a bag of Lego view. Now, we never type tuple view because look how complicated that already is. I just have an image, a text, and a circle, and this thing is complicated. Imagine I added 5 more things to that. It would just start getting out of hand really fast. So what are we going to do here? Well, I'm going to let the compiler help me and replace it with some view. Yeah, you guys are ahead of me there. It's absolutely some view. So now it looks in there and says, oh, yeah, that's a tuple view with an image and a circle and a text. That's going to be its return type. And we never see it. We don't see tuple view. We never type it. We always use some view here. Let the compiler do its work. And now if I go in here and add another thing here, text, howdy, it's working fine. Because that some view just got updated to be tuple view image text text circle probably or something like that. And these things can get quite complicated because I didn't really tell you this, but you can actually have ifs in here. Like I can say if true or false or whatever, then do this. Look, I said if false, greetings is not included here. You see, it's gone. Or if I change that false to be true, now it comes back. So I can have ifs. So that tuple view thing starts getting real complicated if we have ifs and all kinds of just junk in there. So that's why we have some view. Now, we also never do this, by the way, putting this view builder stuff in here. Instead, we take this little code and we inline it. And we're going to inline functions left, right, and center this whole quarter. We call them closures. And I'll tell you later why we call them that, but that's what we're going to do. So I'm going to take this thing and I'm going to cut it, and I'm going to go up here where greetings is and paste it. I inlined it. So now I don't need this whole greetings thing. But you might say, what about the view builder? Okay, I still need the view builder. Well, watch this. I'm going to go look in the documentation for VStack. Actually, I'm going to go all the way into VStack's documentation. I'm going to go down to its init and look at the initializer for VStack. This argument, content, has view builder in front of it. You see? And that's why I can pass a inline curly brace thing that's a view builder to content. So @sign view builder can go on a function, it can go on a var, and it can also go on an argument to a function, okay, or to a creation, just like we see here in the initializer for VStack. So that's why we don't need view builder there. We're almost there. How did we get from this to what we had at the beginning, which was VStack open curly brace? Simple. First thing is, if you have a function or a creation of a struct like this, and the type of the last argument is a function, then you are allowed, incredibly, to remove its label and put the function on the outside of the call. I mean, it's crazy, I know, but you can see it actually looks kind of nice. It's pure syntactic sugar. It's just to make it look nice. It's perfectly fine to do the content way we had before, but this looks nicer. And then, if we had no other arguments here, we wanted the defaults of these two things, then we get this VStack open parentheses close, which this is correct, but another special rule, only if you have a little thing hanging off the end like we have here. In that case only, you can get rid of the parentheses so that you get this beautiful little thing. That's the only time you can remove those parentheses. Like if I went here and removed those parentheses off the circle, errors, because it doesn't have a little function hanging off the end, so you can't do it. So that is all I was going to talk about today. We've basically covered all there is to know about views, putting them together in bags of Lego, how to VStack them together. And we'll talk a little bit more next time about other options, like watch this, HStack. Look, that stacked them horizontally. Or even ZStack, that stacked them on top of each other. We can't see it because of the black circle. They're all black. And next time, we're also going to learn that we can change the colors and the aspect ratios of all this stuff using all those hundreds of modifiers. So we'll see that all next time. And then after we've covered that, we'll dive right into building our CodeBreaker app. Okay, that is it. I will see you next time.